Now we are going to look at exponential and natural log graph. So for exponential, say that we have a function of ex. This is the basic shape of fx equal to ex. As x tends to infinity, fx will go to infinity, and as x tends to negative infinity, fx will tend to 0. Because of that, there will be a horizontal asymptote at y equal to 0 for ex. Horizontal asymptote at y equal to 0 or fx equals to 0. It means that the graph ex will never cross or touch the line y equal to 0. For natural log, as natural log is an inverse function for ex, therefore, the basic shape for natural log is like this. As x tends to infinity, fx will tend to infinity. As x tends to 0, fx will tend to negative infinity. So for exponential, there is a horizontal asymptote at y equals to 0. Therefore, for natural log, there will be a vertical asymptote at x equal to 0. It means that the graph for ln x will never cross or touch the line x equal to 0. The domain for ex is negative infinity to infinity, and the range for ex is 0 to infinity. For natural log, fx exists when x greater than 0. Therefore, the domain for natural log is 0 to infinity, and the range for ln x will be negative infinity to infinity. Okay, this is the third and exponential graph. The blue color is the basic shape. To get the negative of that particular function, we reflect the basic shape to the x-axis. Now, we try to do the natural log function. So basically, this is the basic shape for natural log. Y equal to ln x. When y equal to 0, x will be equal to 1. To get the graph for negative ln x, we reflect the basic shape of ln x at the x-axis. So this is the graph for y equal to negative ln x. For y equals to ln negative x, we reflect the basic shape of ln x at the y-axis. So this is the basic shape of y equal to ln negative x. So here will be negative 1. As ln x to exist. And lastly, for graph negative ln negative x, the graph will be like this. So this is the graph for negative ln negative x. Okay, now we try to look at example 2, sketch the graph of ln x. So to sketch the graph, first we need to have x-axis and y-axis or fx. Fx exists when x is greater than 0. So from here, we just get our domain. Our domain will be 0 to infinity. It means that there will be a vertical asymptote at x equal to 0, and our graph will never cross x equal to 0. So this is the graph. At fx equal to 0, x will be equal to 1, and our range will be all real numbers. For negative ln x and fx, so fx exists whenever x is greater than 0. Now we have our domain. Our domain will be 0 to infinity. It means that there will be a vertical asymptote at x equal to 0. Because we have negative here, it means that our graph, our basic graph, will reflect at x-axis. So this will be 1. Then our range is negative infinity to infinity. So see fx equals to ln negative x. Fx exists whenever negative x is greater than 0. So x will be less than 0. So our domain will be negative infinity to 0. To sketch the graph, there will be a vertical asymptote at x equal to 0, and this is the graph. At fx equals to 0, e0 is equals to negative x, 1 equals to negative x, so x equal to negative 1. And our range is negative infinity to infinity. So for negative ln negative x, fx exists when negative x is greater than 0, so x is less than 0. So our domain will be negative infinity to 0. To sketch the graph, so this is our graph, and this is negative 1. And don't forget to put your asymptote at x equal to 0. Your range will be negative infinity to infinity. Okay, next, e. Ln x minus 1. fx exists when x minus 1 greater than 0. So x must be greater than 1. So from here we have our domain to be 1 to infinity. To sketch the graph, there will be a vertical asymptote at x equal to 1, and our graph will exist at x greater than 1. So this is our graph. At fx equal to 0, e0 is equals to x minus 1, 1 is equals to x minus 1, and x will be equal to 2. So this is 2. So our range is negative infinity to infinity. Fx equals to negative ln x plus 2. Fx exists when x plus 2 greater than 0. So x must be greater than negative 2. So we have our domain. Our domain is negative 2 to infinity. Therefore, to sketch the graph, there will be a vertical asymptote at -2. And our graph must exist at x greater than -2. As we have a negative in front of ln, therefore the basic shape of ln will be reflected at x-axis. This is the basic shape of negative ln x, because we have a negative here. Therefore, at fx equals to 0, 0, negative ln x plus 2, 0 is equals to ln x plus 2, e0 is equals to x plus 2, 1 is equals to x plus 2, so x will be equal to -1. So our x will be equal to -1. Therefore, our graph will look like this. To get the intersection value at fx, so at x equal to 0, fx will be equal to negative ln 0 plus 2 equal to negative ln 2. Therefore, this is negative ln 2. So the range for this function is -infinity to infinity. Okay, let's try to do another example. Before that, we try to sketch the basic graph for ln x. Okay, this is the basic graph for ln x. So this is y equal to negative ln x. Y equal to ln negative x. Y equals to negative ln negative x. So look at G. We want to sketch the graph for negative ln 1 minus x. To find the domain for fx, 1 minus x must always be greater than 0. Therefore, x must be less than 1. And our domain will be -infinity to 1. So to sketch the graph, we know that our graph must exist at x less than 1. So at x equal to 1, there will be a vertical asymptote. By looking at the function, we have a negative in front of ln and negative in front of x. So the basic shape will be like this. So this is the basic shape for negative ln negative x. Now we try to find the intersection at fx equal to 0, negative ln 1 minus x. So 0 equal to ln 1 minus x, e0 will be equal to 1 minus x. So x will be equal to 0. So this graph will intersect at 0. Therefore, this is our graph. And the range will be -infinity to infinity. Okay, we try to look at another example, H. So we have 2 plus ln x plus 1. Fx exists when x plus 1 greater than 0. So x must be greater than -1. So we have our domain will be -1 to infinity. Sketch the graph. So we know that our graph will exist at x greater than -1. At x equal to -1, there will be a vertical asymptote. So as in front of ln, there is a positive, and in front of x is positive as well. So basically the shape of the graph will be a basic shape of ln at fx equal to 0, 2 plus ln x plus 1, negative 2 is equals to ln x plus 1. So e negative 2 equal to x plus 1, x will be equal to e negative 2 minus 1. So this will be e negative 2 minus 1. So our graph will be like this. To get the y value, at x equal to 0, fx will be equal to 2 plus ln 0 plus 1, 2 plus ln 1, 2 plus 0 equal to 2. So this is equal to 2. So our range will be negative infinity to infinity. 3 minus ln x minus 1. fx exists when x minus 1 greater than 0. So x must be greater than 1. So our domain is 1 to infinity. So we know that our graph will exist at x greater than 1. Therefore, at x equal to 1, there will be a vertical asymptote. By looking at the function, in front of ln there is a negative sign, and in front of the x there is a positive sign. Therefore, our basic shape is this, negative ln x. To find the intersection at fx equal to 0, 0 is 3 ln x minus 1, negative 3 is equal to negative ln x minus 1. So 3 is equal to ln x minus 1, e3 is equal to x minus 1, x is equal to e3 plus 1. So this is e3 plus 1, so our graph will be like this. So our range will be negative infinity to infinity. Try to do J and K.